Hello everyone, and welcome to this C# crash course. In this course, we'll talk about every essential topic of C# that you need to know as a beginner or an intermediate programmer. So, let's take a look at what is C# and why should you learn it? C# is a modern programming language created by Microsoft. Think of it as a tool that lets you create all sorts of softwares. What makes it awesome that it's beginner-friendly but also powerful enough for complex applications? It does not matter whether you're a mobile app developer, web developer, game developer, data scientist, or you want to use it for machine learning or deep learning, you can perform all these tasks with C#. This shows that how powerful this programming language is. Now let's talk about .NET Framework and .NET Core. There used to be .NET Framework which used to run only on Windows platforms and .NET Core which could be run anywhere. However, now they've been combined into just .NET. Now, the best part is your C# code can run on any computer whether it's Windows, Mac, or Linux. That's all for the intro. See you in the next section. Now, we'll create setup for C# programming. For that, search for Visual Studio and open this first official link. From here, you can download any version of Visual Studio, but I would recommend you to download Community version as it is free unlike other two which are paid versions. I have already installed it, but let me show something important. Once installer is downloaded, run it. Here, make sure to install .NET Desktop Development Package. It is required to create console apps. After installing it, run Visual Studio. Create new project. Choose console app in .NET Framework. Choose project directory. I'll use latest version of .NET Framework. Our project is created. Now run this app. Right now, console is blank as we have not created anything. Now, let's create our first hello world message. For that, use console.writeLine method and pass it message. Now run the app. Our app closed immediately after showing the hello world message. We need to hold it till user interaction. For that, we'll use console.readKey method. It will hold the console dialog till user presses any key. Now run this app again. Now, message is shown and dialog box is put on hold and is waiting for user input. It closes immediately once we press any key. That's all for this section. Now, we'll talk about variables and data types. So, let's first understand what are the variables. Think of variables as containers that store data in your program's memory. Just like you label boxes when moving house to know what's inside, in C# we give our variables names and types. Each variable needs three things: a type, a name, and a value. Here, string is the data type, message is the variable name, and hello world is the value. Variables can change their values during the program. That's why they're called variables. You can also declare a variable first and assign its value later. Like here, we declared the integer type variable named score first and assigned the value to it later. Now, let's talk about data types. C# has several fundamental data types you'll use regularly. Let's look at each one. First data type is integers. Integer type is used to store whole numbers. Range of integer data type is from -2 billion to +2 billion. It is perfect for ages, counts, or scores. Next comes the long data type. Long type stores the very large whole numbers. It is used when integer type is not sufficient to handle the calculations. Next comes the float data type. Float data type is used for fractional numbers. The precision of float type is from 6 to 9 digits. To assign value to float variables, you must put letter F at the end of the value. Next comes the double data type. Double handles decimal numbers with high precision. Double variables have a precision of about 15 digits. It is safer to use double for most calculations and measurements. To assign values to double variable, you can put letter D at the end of the value. However, you can skip this one. Next comes the decimal data type. Decimal is specifically designed for financial calculations, ensuring precise decimal arithmetic. The precision of decimal type is from 28 to 29 digits. Next comes the string data type. String is used to store the text. It can handle anything from a single letter to long paragraphs. Next comes the Boolean data type. Boolean data type only handle the true and false. It is used in yes or no conditions. Now, let's talk about type conversion and casting. Sometimes you need to convert data from one type to another. C# provides several ways to do this. First is implicit type conversion. Implicit conversion happens automatically when there's no risk of data loss. Like, this integer value can be converted to double type easily without losing any data. Next is explicit type conversion. Explicit conversion or casting is when you force a conversion that might lose data. Like, here we are converting double value to int type. In this method, fractional data is lost and only 99 will be stored in rounded price variable. We can also convert integer or double type value to string type using toString method. Now let's talk about constants. Sometimes you want values that never change, that's where constants come in. We use the const keyword for values that should stay fixed throughout your program. Constants must be assigned a value when declared, and that value can never change. They're great for configuration values or mathematical constants. Also, it is good practice to keep constant variables in uppercase letters. Now, let's talk about the var keyword. The var keyword lets C# figure out the data type automatically based on the value you assign. Remember, var must be initialized when declared, and once the type is set, it can't be changed to store a different type. That's all for this section. Now, we'll talk about operators and expressions. These are the symbols that help us perform calculations, make comparisons, and work with variables. So, let's learn about these. First ones are arithmetic operators. Arithmetic operators let you perform mathematical calculations. The addition operator adds numbers together, like adding two values. The subtraction operator is used to subtract the values. Multiplication operator lets you multiply numbers. Division operator is used to divide the numbers. Finally, there is a modulus operator, which gives you the remainder after division. Next are the comparison operators. Comparison operators help you compare values. They always give you a true or false result. The equals operator checks if two values are the same. Greater than and less than operators check whether values are greater or lesser than the other value. Greater than or equal to and less than or equal checks whether values are greater than or equal to other value or lesser than or equal to the other values. Not equals checks if values are not equal. Next are the logical operators. Logical operators help you combine multiple conditions. The AND operator requires both conditions to be true. The OR operator needs just one condition to be true. The NOT operator reverses a Boolean value. Next are assignment operators. Assignment operators help you assign values to variables. The basic assignment operator simply assigns a value. Compound assignment operators combine arithmetic with assignment. They're shortcuts that make your code cleaner and faster to write. Next is operator precedence. Just like in math, C# follows PEMDAS rules, which are that parentheses are solved first, then multiplication, division, addition, and finally subtraction. When you're in doubt, use parentheses to make your intentions clear because these will be solved first. That's all for this section. Now, we'll talk about input and output methods. Input and output methods make program talk to users and get information from them. This is essential for making interactive programs. So, let's first talk about WriteLine method. WriteLine is your basic printing command. It displays text on the screen and moves to a new line. Think of it as your program's way of talking to the user. You can print text, numbers, or any value your program needs to show. There is also write method. The difference between write and WriteLine method is that write method does not create new line after printing the output. On the other hand, WriteLine methods breaks the line after printing and give the output on new line. We can also use empty WriteLine method to print an empty line to create spacing. Now, let's run this program. Output is displaying the text we provided, and also these strings from write methods are in one line without breaking the line, and empty WriteLine method created this empty space. Now, let's talk about readLine method. ReadLine is used to get text input from users. It waits for the user to type something and press enter. Whatever the user types come in as a string, so you'll need to convert it if you want a number. To get input, we should first use write method to print the query and then use readLine method to get the input from the user. We can then store the input inside a variable. We further wrap this method inside the casting method to convert the input value to other types because by default, input type is string. Now, comment out the previous code and run this program. Now, program displayed the message and is waiting for the user input. As we provide the name, it displays the next message and waits for input again. And same for third time. Now, let's talk about string formatting. String formatting gives you precise control over how your text looks. The placeholder 0 inside curly brackets refers to the first value after the string, and 1 to the second value or variable, and so on. It's like filling in blanks in a sentence. We use this C for currency and the F1 to display 1 decimal digits. We can further use F2 or F3 for more decimal digits. Now, comment out the previous code and run this program. Values are displaying inside the strings as expected. Also, currency is displaying correctly and in second value, only 1 fractional digit is displayed just as we programmed. Now, let's talk about string interpolation. String interpolation is a modern, cleaner way to format strings. To achieve this, just put a $sign before your string and wrap variables inside curly brackets. It's more readable and less prone to errors than traditional formatting. Also, you don't have to deal with order of the numbers like we did in string formatting. Now, comment out the previous code and run this program. Values are displaying inside the strings just as we programmed, but this way it was easier to handle the values because we used these values directly inside the strings. That's all for this section. Now, we'll talk about conditional statements. These are the tools that let your program make decisions. Think of them as the brain of your program, helping it choose what to do in different situations. So, let's first talk about if statements. The if statements are the simplest form of decision-making. If statement checks if a condition is true, and if it is, executes some code. Think of it as asking a yes/no question like if something is true, do this. There is also else block to run the code if the statement is false. However, for complex conditions we also use else if statement. It let us add and handle another condition inside the if-else blocks. You can also add multiple else if statements if you need. Now, run this program. It displayed the first message because first if statement is true. Now, let's talk about switch statements. Switch statements are perfect when you're checking a single variable against multiple specific values. They're cleaner than writing many else if statements for simple equality checks. Like here, we have an integer number. Then we created this switch and passed this number to it. Then we created cases to handle all possible scenarios. And finally, we created a default case to handle if none of the case matches the input value. One thing to note, if we need to run switch on string data types, then we need to add strings to cases to handle possible scenarios. Now, run this program. You can see that Wednesday is printed out because the value of variable was 3. And grade is also shown as grade was B. However, in .NET 8, a modern version of switch statement was introduced. Here in this version, we declared the day number as before. But later we declared a string variable. After that, we used day number variable and then used switch statement. Inside it, we created cases for all possible scenarios, but here we used arrow method and also did not use case keyword as before. Here, as we are returning string data, that's why we created string type variable. Now, we can use this variable to display the returned value. Now run this program. Wednesday is printed. Now, if we change the integer value and run the program again, Thursday is printed. Both switch methods are good. You can use either of these. Now, let's talk about ternary operators. The ternary operator is a shorthand way to write simple if-else statements. It's perfect for quick, simple decisions. In this statement, condition comes first followed by a question mark. Then comes the code to run on true condition. Then add colons and after that add the code to run on false condition. We can store the returned data or values inside the variables and then we can print that data using WriteLine method. Now, run this program. Here, messages from ternary statements are printed. That's all for this section. Now, we'll talk about loops. Loops help you repeat tasks without writing the same code over and over. They're like your program's autopilot for repetitive tasks. Let's talk about for loops. The for loop is perfect when you know exactly how many times you want to repeat something. It has 3 parts: initialization, condition, and increment-decrement value. Like here, I have created a for loop. I have set initial value to 0. In condition, I have set this value to be less than 5. And finally, I have set increment to value. We can also run the loop backwards. Like here, I created another for loop. I have set initial value to 10. In condition, I have set it to be greater than 0. And finally, I used minus to decrement the value. I have another for loop which uses different values to increment or decrement. Inside this loop, I created initial value and condition same as before, but in increment section I used addition operator to increment the value by 2. Now, run this program. Basic for loop ran exactly 5 times from 0 to 4. Decrement loop ran 10 times from 10 to 0. And final loop ran 6 times because it has different increment value. Now, let's talk about for each loop. The for each loop is used to iterate over a collection such as an array, list, or any enumerable data structure without needing to explicitly use an index. The for each loop automatically moves through each element of the collection in order, making it simpler and cleaner to work with collections. Like here, I have created an array of integer type. Don't bother about arrays or lists, we'll learn about these in upcoming lessons. Right now, just focus on for each loop. Then we created for each loop. In condition, I created an integer type variable named number. I used integer type because we want run this loop over array of integer type. Then we used in keyword and then provided the array. In your case, it can be list or any other collection of items. Then inside the loop, I simply printed the number variable. Now, talk about functionality of this loop. The loop starts with the first element of the collection and assigns it to the number variable which we provided. Then it executes the code block. After executing the code for the current element, the loop moves to the next element and repeats the process until it has iterated through all the elements in the collection. Now run the program. Here it printed each item of the array. Now let's talk about while loops. While loops keep running as long as a condition is true. They're great when you don't know exactly how many iterations you'll need. Think of it like saying, keep doing this as long as condition is true. One thing to note here, it checks the condition first and then run the loop. Now, let's understand it using basic while loop. Here, we have integer type count variable. Next, we created a while loop, and in condition, we have set the count to be less than 5. Inside the loop, we printed the value of the variable. Then we increment the variable. It is very important to set the increment or decrement values here, because without these, loop will run infinitely till system crashes. Now run the program. While loop ran exactly 5 times till condition became false. Now let's talk about do while loops. Do while loop is almost same as while loop. There are few differences between them, but we'll learn these few moments later. First, let's see its declaration. To create do while loop, we create do block first. Inside it, we place the code. Then we set the increment or decrement values. After do block, we create while block and set condition. Do while loop runs the code block first and checks the condition later. Now run the program. And do while loop also ran 5 times. Right now, you might be confused that both loops ran 5 times, then why should we not use just another while loop? So, let's talk about difference between while loop and do while loop. To see functionality of both, I have created a while loop and a do while loop. I have created an integer variable here with 0 value. In while loop, I have set the condition to be less than 0, and inside it, we increment the variable. In do while loop, I have put the same condition and increment value. Now, you can clearly see the condition is false because due to increment value is never going to less than 0. Before explaining further, run this program. And we can see here that output of do while loop is printed. You might be thinking that condition is false, then why the loop ran? The answer is, while loop checks the condition first and then run the loop, which means it runs 0 or multiple times. In our scenario, it checked the condition first, which is false, so it stopped and didn't run the loop. However, in do while loop, it executes the code first and then checks the condition, which means it runs at least one time or multiple times. In our scenario, it executed the code and then checked the condition, which is false, so it broke the loop and came out of it. That's why it printed the output once. We use the do while loop in scenarios where we want to run the loop at least one time. So always remember, while loop runs 0 or multiple time, and do while loop runs at least once or multiple times. Now, let's talk about break and continue statements. Break and continue help you control the flow of your loops. Break exits the loop completely, while continue break the current iteration and moves to the next iteration. They're like an emergency exit and a skip button for your loops. Like, here I have created a for loop which runs 10 times. Inside it, I used an if statement to check if value is 5. Inside it, I used the break statement to break the loop. Next, I have created another for loop which also runs 10 times. Inside it, I used an if statement to check if the value is even. And inside it, I used the continue statement to break the current iteration and run the next one. And then, I simply printed the value. Now run the program. We can see that first loop ran 5 times from 0 to 4. But when value became 5, loop broke and didn't run any further. On the other hand, in next loop, only odd numbers are printed. That doesn't mean that loop ran fewer times. Loop ran 11 times from 0 to 10. But due to continue statement, whenever value was even, loop moved to next iteration without the running the code after continue statement. That's all for this section. Now, we'll talk about methods or functions. Methods are like mini programs within your program that help you organize code and make it reusable. So, let's start with method declaration and calling. A method is a block of code you can call multiple times. It has a name, optional parameters, and a return type. The basic structure of a method in C# is return type, method name, parameters, and code to execute. However, parameters are optional. Like here, I created a void type method named sayHello. It does not have any parameter, and inside it, it has the code to execute. Right now, I created this method inside the main method. Now, let's see method with return types. Return types are used to send back the data. Like here, we have a method with integer return type named getAge, and inside it, I used return keyword to return the data back. As return type is integer, we can only send back integer type data. So, I return the value 25. To call these methods, we need to make call from inside the main method using the method name along with parenthesis. As getAge method returned the integer type value, so I created this integer type variable and assigned it the getAge method. Now, this method will be called and returned value will be stored inside this variable. Then, I printed this variable to see the value. Now, run the program. Hello message and the returned value are printed. Now, let's talk about return types in detail. Methods can send back or return values or data of any type like string, integer, double boolean, etc. Methods which don't return any data, we assign void return type to them. Like here, I created 3 methods. CalculateAge returns integer data, getFullName returns string data, and isAdult returns boolean data. Then I create 3 variables and assign these 3 methods to them. One thing to note here, methods return type and variables data type must be same. Then I printed these variables. Now run the program. Here, age, name and boolean value is printed just as we programmed. Now, let's talk about parameters and arguments. Parameters are variables that methods receive, and arguments are the actual values you pass to methods. They let your methods work with different values each time you call them. Like here, I created a void method named greet and inside the parenthesis, I added a string type parameter. Now, we can use this parameter as a variable inside this method. Like, I printed this name parameter just a regular variable. Next, I created a method with integer return type named add, and I added 2 integer type parameters to this method. Inside it, I returned the sum of both parameters using addition operator. Then I called these methods. While calling the greet method, I passed a string value because we added string type parameter in method. Here this value is called argument, and the actual variable passed to the method is called parameter. Then, I created an integer variable named sum and assign it the add method. Then pass two integer type arguments. To pass multiple arguments, I used comma to separate the value. Then I printed the sum variable. Now run the program. Here, hello John message is printed from greet method, and the sum is printed from the add method. Now, let's talk about method overloading. Method overloading lets you create multiple versions of a method with different parameters. The method name stays the same, but parameters change. C# knows which version to call based on the arguments you provide. Like here, I have three methods with same name but return type and data type of the parameters of each method is different. Also, I created these methods outside the main method because overloaded methods can't be created inside the main method. And main is of static type, so we need to declare our methods static, otherwise we won't be able to call these methods from inside the main method without making an object of these. Then, we created three variable and set the data type according the overloaded method. Then I assigned overloaded methods to these variables and passed the arguments according the data types of these methods. Now run the program. Here, values from all three methods are printed. Now, let's talk about optional parameters. Optional parameters have default values and don't need to be provided when calling the method. Like here, I created a method named displayMessage. This method has three parameters. First parameter is required, however, second and third parameters have default values. Inside it, we used an if statement to check if Boolean parameter is true, then print this message, otherwise print message from else block. These default values will only be displayed when we don't pass values to these parameters while calling the method. Then I called the method 3 times. First time, I provided argument to required parameter. Second time, I provided argument to second prefix parameter. And third time, I provided argument to third Boolean parameter. Now run the program. Here, first time message is displayed with default value. Second time message is displayed with provided value. And third time message is displayed with provided value and also timestamp which we set to be shown only when Boolean value is true. Now, let's talk about named parameters. Named arguments let you specify which parameter you're passing values to. They make your code more readable and let you provide arguments in any order. It also prevents several types of errors. Like here, I created a method with 3 parameters and inside it, I printed these parameters. Then I called this method, but this time I also added the parameter name followed by a semicolon and then provided the argument. While using named parameter, we can change the order of arguments like this, because we passing the arguments directly to the parameter itself, so there is no need to follow any order. Now run the program. Here, both messages are printed and are same even when the order of the arguments in second call is not according to order of parameters. And that's only because of named parameters. That's all for this section. Now we'll talk about arrays. Imagine you need to store the scores of all players in a game. You could create separate variables for each score, but that would be inefficient. This is where arrays come in. They allow us to store multiple values of the same type in a single variable. In C#, arrays are type-safe, meaning all elements must be of the same data type. There are 2 types of arrays. First is single-dimensional array and second is multi-dimensional array. Let's first talk about single-dimensional array. A single-dimensional array is a collection of elements stored in a single line, or one dimension, where each element is accessible by an index. Think of it as a row of containers, each labeled by a number starting from 0 up to the size of the array -1. In C#, single-dimensional arrays are a fundamental data structure that allows you to store multiple values of the same data type in a single variable. To create an array, we need to set its data type followed by brackets, then array name, and then initialize it with curly braces and put the data inside it. Like here, I created an integer type array, named numbers, and initialized with integer values. To access the item of the array, we can access it directly by the index of that item. Like here, I'm fetching the first item from the array using 0 index. However, to fetch all the elements of an array, we need to use for loop or for each loop. Like here, I used both for loop and for each loop to iterate over this array. In for loop, I have set length of it equal to length of numbers array. Inside it, I printed the number array by providing it the current index of iteration. In for each loop, I've set it to iterate over the numbers array. And inside it, I simply printed the element of current iteration. Now run the program. Both loops ran 5 times and printed same values. Important note, in C#, arrays have a fixed size once created. You can't add or remove elements. You'd need to create a new array if you want a different size. Now, let's talk about multidimensional arrays. Multidimensional arrays are collections of elements arranged in more than one dimension, like rows and columns. The most common is a 2-dimensional array, often visualized as a grid or table, but you can create arrays with more dimensions if needed, like 3-dimensional arrays represent data in a 3D space. They're useful for representing data in structured formats where you need multiple levels of access. In C#, multidimensional arrays help represent complex data structures, such as a chessboard or a spreadsheet, where data is organized by rows and columns. There are 2 ways to create arrays. First one is this. Here I put comma inside the brackets to declare integer type multidimensional array. Then I initialized it with new integer array with 3 rows and 3 columns. Later, I put curly brackets to add data. Inside it, I put curly brackets again to put data row by row. Each of these curly brackets here represents a row, and each value inside the row represents a column. As we declare this array to be 3 by 3, we must create 3 rows and 3 columns. Second method is to initializing it using shorthand like we did while creating single-dimension array. Like here, I created the new matrix array without specifying the number of rows and columns. I simply put the values and C# will automatically set the number of rows and columns. However, number of columns must be same in all rows. We can directly access an element from the multidimensional array using the index of that element. Like here, I want to access the first element of this array, so I used 0 row index and 0 column index to get the first element. And to get last element of the second row, I used 1 row index and 2 column address. Now run the program. Here, first element of the array and last element of the second row is printed. To access multidimension array, we use for each loop as before. It will automatically get each element of the array from each dimension. Now run the program. Here all elements of the multidimensional array are printed. If we want to use for loops, then we have to create nested for loops. Right now, I created 2-dimensional array, so I need 2 for loops. Like here, I created 2 nested for loops. Important note, we need 1 for loop for each dimension of the array. For example, if you create 3-dimensional array, you need 3 nested for loops, 4 for 4 dimensions, and so on. In first loop, I have set the length using getLength method of array. It returns the length of specific dimension. So, I provided it 0 to get length of first dimension, which are rows. Inside inner for loop, I again used getLength method, but now I provided it 1 to get the length of second dimension, which are columns. Inside it, I printed the element from matrix by providing the index using I and j variables. Now run the program. Here, both for each loop and nested for loops printed the same values. However, nested for loop gives you more control to execute some code over each iteration for outer loop and inner loop separately. Now, let's talk about array method. C# provides several built-in methods for arrays, making it easier to manipulate and manage array data. Let's talk about 3 most basic methods. First comes the sort method. Sort method is used to sort the arrays. Like here, I sorting the numbers array using array.sort method. Now run the program. Number array is sorted. Next comes the reverse method. Reverse method is used to reverse the order of array's elements. Like here, I reversing the numbers array using array.reverse method. Now run the program. Number array is reversed. Next come the index of method. Array.index of method is used to get the specific element of an array. Like here, I created the variable and assigned the index of method. Index of method takes two parameters, first array and second index to fetch. After fetching, we can use this variable anywhere we want without affecting the original array. Now run the program. Element at the index of 3 is displaying here. That's all for this section. Now we'll talk about collections. Collections are a fundamental part of the C# framework that every developer needs to master. Whether you're building a simple application or a complex system, understanding collections is crucial for effective data management. Before we jump into specific collection types, let's understand what collections are. In C#, collections are classes that help us store, manage, and manipulate groups of related objects. Unlike arrays, collections are typically more flexible, can grow or shrink dynamically, and come with powerful built-in methods. There are several types of collections. So, first of all, let's start with lists. A list is the most commonly used collection in C#. Think of it as a dynamic array that can grow or shrink automatically as you add or remove elements. List can be of any data type just like arrays. You should use lists when you need a dynamic collection that can change size, you want to frequently add or remove elements, you need ordered elements with index access, or you want to store multiple elements of the same type. To create a list, we use list keyword. As lists are generic types, so we also specify its data type like this. Then we initialize this list with new list of same data type. Here, we created empty list of string type. If you want to put data in a list at time of initialization, then we can do this by just putting curly braces after the new list, and inside these, we can put data separated by commas. Like here, we put string type data to our list as our list is of string type. We can also add data inside list. To do so, we use add method of the list and pass data to this method. If we want to add data on specific location, then we can do this by using insert method of the list. Insert method takes two parameters, first index to put data and second the data itself. Here, we are putting this name at first index, which is 0. To access a specific element of the list, we can use brackets after list name and put the index of that element. Like here, we are fetching first element by using 0 index. Now run the program. Here, first element of the list is printed. To access all elements of the list, we can use for each loop. Like here, we set this for each loop to iterate over this list, and inside it, we are simply printing the current element from each iteration. Now run this program. Here, all elements of the list are printed. We can also use for loop to access the list elements. Like here, I have used for loop and set the length less than length of the list by using count method of the list. This count method returns the length or count of all elements of the list. Inside this loop, we printed the element of the list by using current index of the loop. Now run the program. Here, this loop also printed the all elements of the list. If you want to remove an element of the list, we can use remove method. Remove takes the value which we want to remove. Like here, I want to remove this person name from the list. However, if you want to remove an element from specific index of the list, then we use remove at method. Remove at method takes the index of the element which we want to remove. Like here, we want to remove second element of the list, so we passed 1 as the index. Then we used for each loop to see the updated list. Now run the program. Here, the elements we removed from the list are not showing, which means these elements are deleted successfully. We can also search for a specific element from the list using contains method of the list. This method takes the element as a parameter and returns Boolean value. Like here, we are searching for this person name in the list. If it exists, it will return true, otherwise it will return false. We can further store this value in a variable to use it later. If we want to know the index of a specific element of the list, then we use index of method of list. This method takes the element as a parameter and return the index. Like here, I'm searching the index of this element. We can also store the index inside an integer type variable like this. Now run the program. Here, the Boolean value from the contains method and index from index of method are printed. Now, let's talk about dictionaries. A dictionary is a collection that stores key-value pairs. Each key must be unique, but values can be repeated. Think of it like a real-world dictionary where each word is unique and has a definition which may resemble. You should use dictionaries when you need to associate values with unique keys or store pairs of related data. To create dictionary, I used dictionary keyword. As it is generic type, we need to set data types of keys and values. Here I want to create integer type keys and string type values, so I set these data types. Then I initialized it with new dictionary with same data types. We can also pass data on initialization time. For that, simply put curly braces after initialization, and inside it, pass data in key value pairs. Here, this integer value is the key, and string is the value. The data types of key value pairs and dictionary must be same. Also, each key must be unique, otherwise it will throw an error. We separate both key and value by comma and then wrap them inside curly braces. Like this, we can add as many key value pairs we want. We can also add data after initialization. For that, we use add method of the dictionary, and inside it, we provide data in key value pair as before. Like here, I'm adding this new key value. Keys must be unique in add method, otherwise it will throw an error. We can also update the values after adding the data. For that, we use the dictionary name and then provide the key in brackets. Like here, I want to update the value of the 5-number key, and then I pass new value to it. One thing to note here, if the key we set does not exist, then it will create new key value pair inside the dictionary. Like here, I passed 6-number key which does not exist right now, so it will now create it. We can also get value corresponding to any specific key. For that, we use dictionary name and pass key in brackets. Like here, I'm fetching the value of key 1. Now run the program. Here it printed the value corresponding to key 1. However, fetching value like this is quite risky and prone to errors. To use it safely, we can use if statement. Like here I used if statement, and in condition I used try get value method of the dictionary, and then passed the key of the value which we want to fetch. Then I used out keyword and created new variable to save the output inside it. Variables data type and values data type must be the same. Inside it, we can use this variable to perform any task. However, I'm printing the value. And in else block, we can print the error message. Now run the program. Here, it printed the value corresponding to key 2. However, if we want to fetch all entries from the dictionary, then we should use for each loop. Like here, I have set this loop to iterate over the dictionary. Inside it, I used this variable to get key and value from the dictionary. Now run the program. Here it printed the all keys and values from the dictionaries. We can also remove the entries from the dictionaries. For that, we use remove method of the dictionary. This remove method takes the key to delete the entry. Like here, we want to remove the entry which got this key. Then we used for each loop again to print updated list. Now run the program. Here, the updated list is printed and it does not contain the entry containing the key value which we removed. We can also get all the keys and values from the dictionary separately in list format. Like here, I created this integer type list to store key, and then initialized with dictionary.keys.toList method. This method will store all the keys from the dictionary inside this list. We did the same for the values, but here we used value instead of the keys. It will store all values in list format inside this list. Then I used 2 for each loops to print keys and values from the lists. Now run the program. Here, all the keys and values are printed separately. Now, let's talk about hash sets. A hash set is a collection that stores unique elements in no particular order. It uses hash codes for fast operations and automatically handles duplicate prevention. Think of it like a bag that keeps unique items and automatically discards any duplicate items you try to put in it. You should use hash set when you need to ensure element uniqueness. You want fast lookup operations. You don't need to maintain element order. You need to perform set operations like union, intersection, etc. To create hash set, we use hash set keyword like I did here. We also need to provide the data type of this hash set. Then we initialize it with new hash set. We can add items to it hash set on time of initialization. For that, Put curly braces after initialization and inside put items separated by commas. Data type of items and hash set must be same. We can also put items in hash set after initialization. For that, we use add method of the hash set and inside it, we provide the item. This add method checks hash set to prevent duplicate values. If the item already exists, then it will cancel the operation and will return false Boolean value. If item does not exist, then it will add the item in hash set and will return the true value. We can save the returned value in a variable like I'm using this variable to store the result. Like here, I'm adding 2 items in hash set. First item is unique but second item is duplicate. Now run the program. Here, true and false messages are printed, which means first item is added but second items got rejected because it was duplicate. We use for each loop to get all items of the hash set. Like here, I've created this for each loop to iterate over this hash set. Inside it, I'm simply printing the items of the hash set. Now run the program. All the items of the hash set are printed here. We can also remove the item from hash set. For that, we use remove method. Inside it, we provide the item which we want to remove. This remove method also returns the Boolean value to represent the result of the task. We can store the returned value just like I did. Now run the program. True is displayed here, which means item is removed successfully. We can also perform certain set operation on hash sets like combining, intersecting, etc. Like here, I have created another hash set. Inside it, I have put some values which also exists in the first hash set that we created. Now, let's see set operations one by one. Here, I'm using this union with method of the hash set and also pass the new hash set to this method. Union with method combines the both sets by putting the items of both set inside the set on which this method is used. In our case, it is unique set, so this method will combine the both sets inside the unique courses. However, it will ignore the duplicate values. Now run the program. All items of the both sets are printed here. However, duplicate items are ignored. Now comes the intersect method. This method keeps the common items of the both sets. Like here, we used intersect with method on the unique courses set and past science courses set to this method. Now run the program. It printed the common items of the both sets here. Now comes the except method. This method removes the items from the first set which exist in the second set. I'm again using this method on unique courses set and providing it the science courses set. Now comment out previous method to provide original sets to this method. Now run the program. Here are values which exist in the first set but do not exist in the second set. That's all for this section. Now, we'll talk about classes and objects. Classes and objects are the fundamental building blocks of object-oriented programming in C#. These are essential for creating robust, maintainable, and scalable applications. So, let's talk about classes. In C#, classes are the fundamental units that encapsulate data and behavior. Classes provide a way to group related properties and methods together, making your code more organized and easier to understand. We can create multiple classes inside one file or each class in separate file. It's good practice to keep each class separate. However, for demonstration, I'm creating new class inside this file. I created new class outside this program class which contains main method. To define a class in C#, you use the class keyword, followed by the name of the class. Here, public access modifier means these class members are accessible from anywhere in your code. Inside the class, you can declare fields, properties, methods, and other class members. Like here, I created 2 class fields. After these, I create method named introduce. Inside it, I simply printing the value of these fields. However, if we run program now, nothing will show up because we have not called this introduce method in main method. Before implementing that, we need to learn about few things first. So, let's talk about properties. Properties are a special type of class member that provide a way to access and manipulate the data stored in fields. They allow you to add validation, perform calculations, or add extra logic when getting or setting the value of a field. Let's understand it with code example. Here I created this separate bank account class. Inside it, I create private field with decimal data type. By making it private, we can't access this field from outside the class. So, here properties come into play and solve this problem. Here, I create a public property named balance with decimal data type. Inside this property, I created get and set methods. To create get and set methods, we simply use get and set keywords. Inside get method, I'm returning the private field. In set method, I using if statement to ensure the negative value is not stored. Set method is used to set values, so it has a value parameter. We can use it to get the value which is passed to this method. Then in else block, I'm simply assigning the value to the private balance field. This way, we are ensuring that no one access the private field and perform any other operations on it. We are only using this property to get and set the values. Then I created two deposit and withdraw methods. These methods take decimal values as parameters. Inside these, I'm accessing this property to update balance field. This way, no one can access the private field and it also provides an extra layer over the data. Now, let's talk about constructors. Constructors are special methods that are called when an object of a class is created. They allow you to initialize the object's state with the necessary data. A constructor name must be same as the class name. Like here, in person class, I created two properties with same name and data type instead of fields. We can use properties without the fields. Inside these, we can use only get and set keywords. These will automatically get and set the values while calling and passing data to these. Then I created constructor of this class using the class name. Inside this constructor, we simply printed the message. Now, to see the outcome, we need to create object of this class in main method. So, let's talk about objects and instances. Objects are instances of a class, which means they're concrete representations of the class with their own unique data. You create objects using the new keyword, which calls the class's constructor to initialize the object. To create object, we use class name, then we set the object name. Then we initialize it by providing new keyword and name of that class. Now run the program. Message is printed here. Now, let's talk about parameterized constructors. A parameterized constructor is a constructor that accepts one or more parameters. These parameters allow you to set initial values for properties when you create a new instance of the class. By using parameterized constructors, you can ensure that objects are always created with valid initial values. Like here, I created the constructor just like before, but this constructor takes two parameters. Inside it, we are passing parameter values to the properties of the class. Then we created new object of this class. But we provided the argument to constructor on initialization time. C# will automatically call the constructor corresponding to these values, which also means that we can create multiple parameterized constructors just like overloaded methods. Now, to call the introduce method from the class. We can use the object of this class and put method name we want to call. I want to call introduce method. One thing to note here, I called this method using both objects of this class. Now run this program. Here we can see that values are not displaying in the first message one but are showing in second one because we called empty constructor in first object and called parameterized constructor on second object. Both objects hold separate version of that class. So, let's talk about class methods. Methods are the actions that a class can perform. They encapsulate the logic and behavior of your class and can accept parameters and return values. Like here, we created this introduce method to print the message. You can learn about methods in the 8th section of this course because everything is same. In that section, we talked about methods in detail, so check that out if you skipped that section. That's all for this section. Now, we'll talk about object-oriented programming. Object-oriented programming concepts are the fundamental principles which will help you write better, more organized, reusable, and maintainable code. There are 4 pillars of OOP: encapsulation, inheritance, polymorphism, and abstraction. Let's talk about encapsulation. Encapsulation is the concept of bundling data and the methods that operate on that data within a single unit or object, while restricting direct access to some of an object's components. Think of it as a protective wrapper that keeps the data and code safe from outside interference. Like here, we have class named backAccount. Inside it, we have a private field which we don't want to be accessed directly from outside this class due to security reasons. Then I created a property which returns the balance in get method. However, we again made set method private to restrict its access. Then I created a deposit method. It takes decimal type parameter. Inside it, I used if statement to prevent negative amount to be submitted. Inside it, I simply added the amount in balance. Next, I created a Boolean type withdraw method. It also takes decimal type parameter. Inside it, I used if statement to check that amount to withdraw should not greater than balance and also should not be negative value. Inside it, I deducted the amount from balance and returned true to show successful transaction. Outside if statement, I returned the false to show rejected transaction. This way, I prevented the direct access to balance from outside of the class completely. Users can only access it in controlled manner by using deposit and withdraw methods. This whole method of encapsulation of the data is called encapsulation. Now, let's talk about inheritance. Inheritance is a mechanism that allows us to create new classes based on existing classes. It enables code reuse and establishes a relationship between parent and child classes. Like here, we have vehicle class. Inside it, I created 3 properties. Then, I created a parameterized constructor of this class and initialized all 3 properties inside it. Then I created a virtual method to display all these properties. I made this method virtual, so I could override this method in child classes. We'll see it in few moments. Then I created a car class which inherits from vehicle class. We use colon to define inheritance. Inside it, I created a property for this class. Then, I created parameterized constructor of this class. In the constructor, I required 4 parameters: brand, model, year, and doors. Then I used colon and use base keyword and passed 3 of these 4 parameters to it. And inside it, I initialized property with doors parameter. Now, pay attention here. I required 4 parameters here because base class also requires 3 parameters, because we required these in constructor of base class. So, I had to provide these to base class. To implement that, I used base keyword. Base keyword is used to send data to base class. Here, I provided these 3 parameters to it. So, its requirement is fulfilled. Then I initialized the property of this class inside the constructor, so it's also complete. Then I created a method with the same name as we created in base class. But here, I used override keyword because I want to override that method. When a method is marked with override in a derived class, it replaces the base class's version of that method with the new implementation in the derived class. This allows derived classes to change or extend the behavior of the base class method. Inside this method, I'm calling displayInfo method from base class using base.displayInfo. In base class, we are printing the properties in displayInfo method. After that, I'm printing the property of this class here. Then I created the object of car class and also passed arguments to the constructor. Then I called this displayInfo method of this class using this object. Now run this program. Here, you can see that brand, model, and year is printed from the base class and the number of doors line printed from the car class. This is how inheritance is implemented. You can inherit multiple classes from the vehicle class like this. Now, let's talk about polymorphism. Polymorphism is a concept that allows objects of different classes to be treated as instances of the same base class. It enables a single interface or class to represent different underlying forms. It comes in 2 forms: compile time, which is method overloading, and runtime, which is method overriding. Let's see method overloading first. In method overloading, multiple methods in the same class have the same name but different parameter lists. The compiler determines which method to call based on number and type of parameters. Like here, I have a class named mathOperations. Inside it, I have 3 methods with same name. However, each method has either different parameter types or return type. Like first method takes 2 parameters, second method takes 3 parameters, third method takes 2 parameters but it takes double type parameters and return double type value. Then I created object of this class. After that, I called this add method 3 times. To first method, I passed 2 integer type arguments. To second, I passed 3 integer type arguments. And to third, I passed 2 double type arguments. After running it, compiler will automatically call the corresponding method according to parameter types and parameter numbers. Now run the program. Here, we can see the correct output, which means each method was called correctly by compiler automatically. Now, let's see method overriding. In method overriding, a derived class provides a specific implementation for a method already defined in its base class. The overridden method in the derived class replaces the base class's method at runtime when called through a base class reference. Like here, I created this animal class. Inside it, I created a virtual method named speak. Inside it, I'm simply printing a message. After it, I created a class named cat which inherit from animal class. Inside it, I create a method named speak with override keyword. Inside it, I'm printing a message. Due to override keyword, this method will implement its own code on runtime. Then I created another class named dog which inherits from animal class. Inside it, I created speak method again with override keyword. Inside it, I'm printing a message again. Now, make object of all these classes. Then I called speak method from every class using object of that class. Now run the program. Here you can see that output of each method is different because each method has different code to implement. Important thing to note here. In method overloading, the method to call is determined by the compiler based on the method signature. And in method overriding, the method to call is determined at runtime based on the actual object type, enabling dynamic behavior. Now, let's talk about abstraction. Abstraction is the concept of hiding complex implementation details and showing only the essential features of an object. Abstraction allows you to define classes, methods, and properties that focus on what an object does rather than how it does it, providing a simplified interface for interacting with complex systems. In C#, abstraction is achieved through abstract classes and interfaces. Abstract class is a class that cannot be instantiated on its own and often contains abstract methods that must be implemented by derived classes. Interface is a class that defines a contract that classes must follow, specifying method and property signatures without any implementation. Let's see abstract classes first. An abstract class can contain abstract methods without implementation and concrete methods with implementation. Derived classes must implement the abstract methods. Like here, I created a shape class. Inside it I created a calculate area method with no code implementation and used abstract keyword to make it abstract method. Then, I created a display method with code implementation. Inside it, I displayed a message. Then, I created a class named circle which inherits from shape class. Inside it, I created a radius property. Then I created a parameterized constructor and initialized the radius property inside it. Here, we can see the red line which indicates the error. It is showing because we need to implement the calculate area method of base class. Then I created overridden calculate area method. Inside it, I implemented the code to calculate area. Then I created another class named square. Inside it, I created side named property and initialized it inside the parameterized constructor. Now, I have to implement calculate area method. So, I created this overridden method and implemented the code to calculate the area inside it. Then, I created objects of circle and square classes and also provided the values to constructors. Then I called the display method of the base class through these objects because both base and child classes are now related and I can call method of base class through child class. Then I called the calculate area method using these objects. Here, I'm calling same method but with different class object. Now run the program. Here we can see that message from display is printed twice and values from calculate area is also printed. Now let's see interfaces. An interface defines a contract that implementing classes must follow, ensuring they provide specific methods or properties. Interfaces provide even higher levels of abstraction because they do not contain any implementation. Difference between interface and previously explained abstract class is that an interface has no implemented methods inside it. All methods are defined to be implemented in child class. Like here, I have class named iMove. It's a convention to start interface name with an I. Inside it, I defined method move. Then I created two classes named car and robot. Both of these classes inherit from move interface class. Inside these classes, I implemented the move method. Now, there's no need to put override keyword. Then I printed two messages inside these methods. Then I created objects of these two classes and called this move method through these. Now run the program. Here we can see that messages from both move methods are printed. This is how we implement abstract classes and interfaces. Purpose of these is to hide the complex implementation and exposing only essential details. That's all for this section. Now, we'll talk about types of classes. C# offers various class types to help structure and optimize your code for different scenarios. So, let's start with standard class. Standard classes are the most commonly used in C#. They define reusable blueprints for creating objects and can include instance members like fields, properties, and instance methods. They enable encapsulation and object-oriented programming features like inheritance and polymorphism. Like here, I have car class which has a make property and drive method. To access the properties and methods of this class, we have to create object of this class. Next are static classes. Static classes are used when you need functionality not tied to an object. They cannot be instantiated and contain only static members. Static classes provide utility or helper functions, like mathematical operations, without requiring object creation. Like here, I created a static class and inside it, I created a method named message which prints a string message. We can access the properties and methods of this class directly without creating object of this class. Next are abstract classes. Abstract classes serve as templates for other classes. They cannot be instantiated and can define abstract methods, which must be implemented by derived classes. These are useful for creating a common base class with shared logic while enforcing specific implementations in derived classes. Abstract classes are used for partial implementations where some methods are defined and others are left for subclasses. Like here, I have an abstract class and inside it, I have defined an abstract method. Then I created circle class which inherits from shape class. Inside it, we had to implement the abstract method of the shape class. So, I overridden the area method to implement it. To access it, I created object of shape class type and initialized it with circle class and provided the radius to it. Then we can access the area method without any error. Next are sealed classes. A sealed class cannot be inherited. It is used to restrict further extension of a class. It prevents unintended inheritance and may offer performance optimizations. It is used for security or when a class is finalized and shouldn't be extended. Like here, I have a sealed logger class. Inside it I have created a log method to print the message. We can create object of this class like standard classes to access methods and properties of it. Next are partial classes. Partial classes allow splitting a class definition across multiple files. It's helpful for organizing large classes or auto-generated code. It enhances code readability and simplifies management of large projects. Like here, I have two partial classes. These act like two separate parts of one class. These classes can be placed inside different files. After creating object of this class, we can access properties and methods of both classes because these parts of each other. I created two partial classes, but you can create multiple partial classes. Next are nested classes. A nested class is a class defined inside another class. It provides encapsulation and helps logically group related functionality. These classes increase encapsulation and keeps related functionality within the same context. We create the object of this class using the outer class because inner class is now only accessible through outer class. After that, we can access properties and methods of it like normal classes. Next are anonymous classes. Anonymous classes are temporary types with read-only properties, often used in LINQ for data grouping. These classes simplify temporary data grouping. Like here, I've created this variable person and passed an anonymous class to it. Inside it, I also pass some data. We can use this class name to access the properties of this class. Next are extension classes. Extension classes allow adding new methods to existing classes without modifying their code. Defined as static methods in static classes, they extend the functionality of the target type. These enhance code reuse without altering original types. These are commonly used for helper functions. Like here, I have static type class string extensions. Inside it, I created the static Boolean type method to check whether the word is palindrome or not. This adds a isPalindrome method to the string class, making it reusable across the codebase. Then we can use it like any normal string method offered by C# by default. Like here, I used it to check this string variable. After running the program, we can see the true message returned by the extension method. Also, the messages and values from all other classes are printed. That's all for this section. Now, we'll talk about advanced class concepts. C# offers a variety of advanced class features that make object-oriented programming more efficient and structured. Understanding these concepts can help you write cleaner, more reusable and maintainable code. We have already explained fields, properties, method overloading and overriding, and interfaces. Now, we'll learn about static members, access modifiers, and constructor chaining. So, let's talk about static members. Static members are variables, properties, or methods that belong to the class itself rather than to any specific object of the class. This means they are shared across all instances and can be accessed directly using the class name. Static members are useful for creating constants or utility functions. Like here, pi is a static field, and calculate circle area is a static method. You don't need to create an object to use them. We can directly call static fields and methods. This ensures that the logic is centralized and reusable. Now run the program. Here, value of pi and radius is printed. Now, let's talk about access modifiers. Access modifiers determine the visibility of classes, fields, methods, and other members. They ensure proper encapsulation and help protect data from unauthorized access. In C#, the most common modifiers are public, private, protected, and internal. Like here, I have a messages class. Inside it, I created a public message with public access modifier. Members marked as public are accessible from anywhere in the program. This means any class or object can access them without restriction. Public members are typically used when you want the member to be globally accessible. Next, I created a private message with private access modifier. The private modifier restricts access to members within the same class. These members cannot be accessed directly outside the class. Private members are useful for encapsulating data and ensuring it can only be accessed or modified through controlled methods or properties. To access this private message, I created this public method which prints private message. Next, I created a protected message with protected access modifier. The protected modifier allows access to members within the same class and any derived or child classes. It is commonly used in inheritance scenarios where a base class wants to provide some functionality to its derived classes while keeping it hidden from other classes. Like here, I created a derived message class which inherits from messages class. Inside it, I created a public method which prints the protected message from the base class. Next, I created an internal message with internal access modifier. The internal modifier makes members accessible only within the same assembly. It's useful when you want to limit access to certain functionality to other classes within the same project but hide it from external projects. Like here, I created this internal message with internal access modifier. After this, I created object of this class. Then I printed the public message directly. Next, I used this method to show private message because I can't access the private field directly. Next, I printed the internal message. I'm able to access it because I'm fetching it in same assembly. Then, I created the object derived class and used this method to print the protected messages because I can't access it directly. Now, run the program. Here, all messages are printed. Now, let's talk about constructor chaining. Constructor chaining is a way to call one constructor from another within the same class or between base and derived classes. This helps reduce code duplication and ensures consistent initialization. Like here, I've created a vehicle class. Inside it, I have a string type property. Then I created a parameterized constructor which initializes the type property inside it. Then, I created a default constructor and called the parameterized constructor of this class using this keyword. Then I passed the string type value to it. It will call the parameterized constructor automatically corresponding to the value type. Then, I created object of this class. After that, I printed the type property of this class. Now run the program. Here, we can see that car is printed, which means default constructor called the parameterized constructor and passed this value to it. That's all for this section. Now, we'll talk about exception handling in C#. We'll cover the fundamentals like try-catch blocks, multiple catch blocks, the finally block, throwing exceptions, and even custom exceptions. So, let's talk about try-catch blocks first. In C#, exceptions are unexpected errors that disrupt the flow of a program. The try-catch block is the fundamental way to handle exceptions. The try block contains the code that might throw an exception, while the catch block handles it. Like here, I have a string message. Then I created the try-catch block. Inside try block, I tried to convert this string into integer format. This will cause an error or exception. Now to handle the exception, I created the catch block, and inside it, I set it to catch exception and also made object of it. Inside it, I printed the error message. This message will only show up when there's an exception in our code, otherwise this block would not run. Now run this program. Our error message is printed here. This way, we handled the exception and also our program didn't crash unexpectedly. Now, let's talk about multiple catch blocks. You can handle different types of exceptions separately using multiple catch blocks. This is useful when different actions are required for different errors. Like here, I have an array with some data inside it. Inside try block, I tried to access the 5 element of the array which does not exist in this array. So, it would cause index of bound exception. Next, I created a catch block and set it to catch index out of range exception. Inside it, I printed the exception message. Next, I created another catch block to catch any other exception. And inside it, I also printed the exception message. This way, we can create multiple exception for different types of exceptions. Now run the program. Here, index out of bound exception is captured and printed. Now, let's talk about finally block. The finally block contains code that always executes, regardless of whether an exception was thrown. It's often used for cleanup tasks like closing files or releasing resources. For example, we use it for database operation. In try block, we try to access the data. In catch block, we handle the possible exceptions. And in finally block, we close the database connection because we need to close it in any situation. Like here, I created a stream reader. Don't worry about it, we'll learn about it in upcoming section. In try block, I used it to read text file which does not exist. Next, I used read to end method to print the content of this file. Next, I created the catch block to catch and print the exceptions. Then I created finally block. Inside it, I used if statement to check if reader stream is not null. Inside it, I closed the reader stream. Because we have to close the stream in any case whether operation was successful or not. It guarantees resource management and cleanup operations. Now run the program. Here, exception message is printed because file we entered was not found. Now, let's talk about throwing exceptions intentionally. Sometimes, you may need to throw an exception intentionally to signal an error. You can use the throw keyword for this. It used to validate data or to enforce business logic. Like here, I have a method which takes integer parameter. Inside it, I used if statement to check if the age is less than 18. Inside it, I used throw keyword to throw new exception and also pass the exception message to it. Then I created try catch block and called this method inside try block and passed the argument which would cause the exception to arise. Next, I created the catch block and printed the exception inside it. Now run the program. Here, the message from the exception is printed. This way, we throw the exceptions intentionally. Next, let's talk about custom exceptions. C# allows us to create custom exceptions. You can define your own exception classes to represent specific errors in your application. This makes your code more meaningful and easier to debug. Custom exceptions make your error handling more specific and self-documenting. Like here, I created a age exception class which inherits from exception class. Inside it, I created a parameterized constructor and required string type message and parameter. And also passed this message parameter to base class using base keyword. Then I created a method which checks the age just like before, but this time throws different age exception which we just created. Then I created try catch block, and in try block, I called the custom exception method and passed argument to it. Then I created the catch block which handles the age exception. Inside it, I printed the exception message. Now run the program. Here, the custom age exception message is printed. This is how custom exceptions are created and handled. That's all for this section. Now we'll talk about file operation. File handling is a fundamental skill for working with data storage and retrieval. You'll learn how to read and write text files, manage files and directories, and use file streams for more advanced scenarios. So, let's talk about file reading. To read the file, we need file path first. Like here, I have example text file here. So, I copied path of this file and stored it inside this variable. Then I used if statement and use file.exists method to check whether file exists or not. Inside it, created a string type variable and initialized it with file.readAllText method and passed file path variable to it. After it, I printed the content variable. Then I created else block to print error message in case file does not exist. Now run the program. Here the content of example text file. Now, let's talk about writing text. There are two ways to write text to a file. First method is to overwrite the current file which delete all existing content of the file, and second method is to append the text which add text after existing content of the file. We'll see writing first. Here I have a string which I want to write in the file. Then I used file.writeAllText method and passed file path to it, and then passed the content to write inside that file. Now run the program. The content we wanted to write in written successfully. We can also check it by opening the file. Now, we'll see appending file. Here, I have a message to include in the file. Then I used the file.appendAllText method and passed file path and text to write in the file. Now run the program. Now open the file. Text is successfully added in the file. Now, let's talk about creating file and directories. We can also create directories and files. Like here, I have a path which I want to create. Next, I have file path which I want to create inside this directory. For that, I use path.combine method and pass directory path to it, and then pass the file name which I want to create. Then I used the if statement and used directory.exists method to check if directory path exists. I also used exclamation mark to negate the condition. Inside it, I used directory.createDirectory method and pass directory path. This method will create directory. Then I used another if statement and used file.exists method to check if file exists and also negated the condition. Inside it, I used the file.writeAllText method and passed file path and content to be added. This write method will create file automatically if file does not exist. Now run this program. It shows the success message. Now go to project directory to see the new file. New directory is created here. Inside it, new example file is created and the text is also added inside this file. Now, let's talk about file streams. For more control over file handling, use file streams. File streams let you read or write data byte by byte, making them ideal for working with binary files or large datasets. Like here, I created using statement. Here, using statement is used with file streams to ensure proper resource management. File streams work with underlying system resources, such as file handles, and these resources need to be released when no longer needed. The using statement automatically handles this cleanup by calling the dispose method of the object when the block of code is exited, even if an exception occurs. First, we'll see write text to file. For that, I created the object of file stream and passed file path and file mode to it. Right now, I want to create or write file, so I'm using create mode. Inside it, I created byte array and initialized it with encoding.utf8.getBytes method and passed content to it which I want to write in file. Here, getBytes method will convert string into bytes. Then I used the write method from FileStream object, and passed byte array to it, then passed 0 as inset and passed the data length as the count to it. Here, this 0 specifies the starting position in the data array from which writing begins, and the count specifies the number of bytes to write from the data array. Now run the program. Success message is printed. Now open the file. Here is the content which we added using FileStream. Now we'll see reading from file using FileStream. Here, I created using statement again and created object of FileStream inside it. Then I passed file path to it, and also I have set the file mode to open as I want to read content from the file. Inside it, I created new byte array named buffer and initialized it with new byte array and passed it FileStream.length. Then I used the read method of FileStream and passed it buffer array 0 as inset and buffer length as count. Then I created string type content variable and initialized it in coding.utf8.getString method and passed buffer array to it. This getString method will convert bytes into string. And then I printed the content. Now run the program. Content of the file is printed here successfully, which means read and write methods are working perfectly. That's all for this section. Now we'll talk about best practices. Whether you're just starting out or looking to improve your skills, these tips and techniques will help you write cleaner, more efficient, and maintainable code. So, let's talk about naming conventions first. Clear and consistent naming makes your code easier to read and understand. In C#, use Pascal case for methods names and class names, like this process order method name. Use camel case for variable and parameter names, such as order count or customer ID. For constants, use uppercase letters with underscores, like max limit or pi. These conventions improve readability and align your code with industry standards. Now, let's talk about code organization. Good code organization is crucial for maintainability. Separate your classes into logical groups using namespaces and place related classes in the same folder structure. Keep methods short and focused, each performing a single responsibility. Use regions to collapse sections of code and improve navigation in large files. Like here, I have separated content of each section in separate classes. Just like this, separate all tasks of your program in separate classes to increase code readability. Now, let's talk about comments. While writing code, always remember to add meaningful comments, especially when multiple persons are working on same project. Comments help developers by providing them the summary of the code block. Like here, this method takes list of integers and returns the sum. I explained the working of this method in this comment, so other person gets the idea about this method and its working. So, it would also help that person in debugging the code if any error occurs. Now, let's talk about proper exception handling. One common mistake many developers make is that they do not handle exceptions properly. Always wrap sensitive code in try-catch blocks and avoid leaving resources open by using statements. Like here, I've created a simple example of a database connection using the using statement and try-catch block. Using statement handles the memory and try-catch block handles the exceptions. This way, I also handled the memory and exceptions. Now, let's talk about when to use each class type. Each class type in C# serves a unique purpose. Use standard classes for general functionality, static classes for utility methods, and abstract classes when you need to enforce a contract with some shared logic. Interfaces are great for defining behavior across unrelated classes. Be thoughtful about which type best fits your design needs. That's all for this section. As this crash course is completed, now we'll create some projects to implement all the things which we learned in this course. First of all, we'll create a console calculator app. Here, I have created a Boolean variable and set it true. Then, I created while loop and passed this variable as condition to it. Inside it, I asked for first number, then created this number1 double type variable and initialized it with this getValidNumber method. Inside this getValidNumber method, I created a while loop and passed true to it run infinitely till user provides correct value. Inside it, I created if statement and used readLine method in condition to get user value. Then I wrapped this method inside double.tryParse method to convert it to double type, and then I saved the provided value in this number variable. and then I returned this number variable. In else block, I simply printed the error message. Returned Boolean value would be stored in this variable. Then I asked for operation, and then created this string type operation variable and initialized it with getValidOperator method. Inside getValidOperator method, I used while loop and passed true as condition. Inside it, I created string type operation variable and initialized it with readLine method to get user input and also used this trim method to remove all white spaces from the user input. Then I checked the valid operator using if statement and returned the operation variable in case the input is valid, and in else block, I printed the error message. Then I asked for second number and created this number2 double type variable and initialized it with getValidNumber method. Then I created double type variable named result and initialized with perform calculation method and passed number1, number2 and operation as arguments to this method. In this perform calculation method, I required 3 parameters. Inside it, I used switch statement passed operation as condition to it. Inside it, I created case for all operations and performed calculations according to operation and returned the value. In division, I used ternary operator to prevent division by 0. And also throwed the exception if operation is not valid. Then I printed the result variable. After it, I asked the user if he wants to perform another calculation. Then I created string type variable named continueResponse and initialized it with readLine method, and used trim method to remove white spaces and also used toLower method to convert the input into lowercase. Then I used the keepRunning Boolean variable and initialized it with this expression. It will check if response is equal to yes, then it will return true, and while loop will perform another calculation, otherwise it will return false and loop will stop. Now run the program. It asks for first number. Provide wrong value. It gives error. Now give valid input value. Now it asks for operation. Give wrong input. It returns error. Now give valid input. Now provide second number. It printed the correct result, and also asks user for another calculation. If we provide yes, then loop will run again. After another calculation, if we provide no as input, the loop will break. With this, calculator app is complete. Now we'll create banking app. Here, I created accounts dictionary of int and bank account type and initialized it with new dictionary. Bank account is a class. In this class, I have 3 properties, account number, name and balance. Then I created parameterized constructor and initialized these properties inside it. Then I created deposit method which takes double type parameter. Inside it, I add this amount and balance. Then I created Boolean withdraw method which also takes double type parameter. Inside it, I used if statement to keep withdraw amount lower than balance. Inside it, I deducted the amount from balance and returned true to indicate successful transaction. Then I returned false in case of errors. Then I created Boolean type variable and set it true. Then I created while loop and passed this variable as condition. Inside it, I printed the options for operations. Then I created string type choice variable and initialized it readLine method to get user input. Then I created switch and passed choice variable as condition. Then I created case for each operation and called the method accordingly. Each method requires accounts dictionary, so I passed it to all method. Let's see create account method. In this method, I'm first getting the user's name and storing it in name variable. Then I'm getting initial deposit amount by calling getValidAmount method and stored the amount in initial deposit variable. Inside this getValidAmount method, I created while loop and passed true as condition. Inside it, I'm using if statement and in condition, I used readLine method and wrapped it inside double.tryParse method to convert the input into double type. Then I created the amount variable to store the input, and also checked that amount must be greater than 0. Inside it, I returned the amount, and in else block, I printed the error message. Then I set the account number equal to account count plus 1. Then I used that account number from account and initialized it with new bank account and passed account number, name and initial deposit amount. And then printed the success message along with account number. Next, I created deposit method. Inside it, I'm getting account number by calling getValidAccountNumber method and stored the input in account number variable, and also passed this account parameter to it. Inside this getValidAccountNumber method, I created while loop and passed true as condition. Then I created if statement and used readLine method in condition, and wrapped this method inside int.tryParse method to convert the input into int type. Then I created account number variable to store input, and also used account.contains_key method and provided this account number to it. This method will look for account number in dictionary, and if account number is not found, then it will return false. Inside it, I return the account number, and in else block, I returned error message. Then I created amount variable and called getValidAmount method to get the amount to deposit. After that, I accessed the user account from accounts using account number and using the deposit method and passed the amount variable to it. Then I printed the success message and also printed the new balance. Next, I created the withdraw method. Inside it, I asked for account number using getValidAccountNumber method and stored the input value in account number variable. Then I asked for amount to withdraw using getValidAmount method and stored the input value in amount variable. Then I created if statement and called withdraw method using account number. This method will return true on successful transaction. Inside it, I printed the success message along with updated balance. And in else block, I printed the error message. Next, I created the check balance method. Inside it, I asked for the account number using getValidAccountNumber method and stored the input value in account number variable. Then I printed the account holder's name and balance from the accounts dictionary using the account number. Now run the program. Options are displaying here. Select one to create account first. Add name and initial amount. Then select 2 to deposit. Enter account number first. Then enter amount. Then select 3 to withdraw some amount. Enter account number. Then enter amount to withdraw. Then select 4 to check the balance. Enter the account number. Account holder's name and the balance is printed. Now select 5 to exit. And the program is closed. With this banking app is complete. Now we'll create Shapes Calculator app. Here, I have list of shape type. Shape is an abstract class, which have 2 abstract methods to calculate area and perimeter. Next, I have created a circle class which inherits from shape class. Inside it, I have radius property and initialized it in parameterized constructor. Then I implemented the both methods of abstract class by overriding. And inside these methods I implemented the formulas to calculate area and perimeter of a circle. Next, I have created a rectangle class which inherits from shape class. Inside it, I created length and width properties and initialized these in parameterized constructor. Then I implemented the abstract methods, and inside these, I implemented the formulas to calculate area and perimeter of a rectangle. Next, I have created a triangle class. Inside it, I have 3 properties for each side of a triangle. Then I initialize these properties inside the parameterized constructor. Then I implemented the abstract methods, and inside these methods, I implemented the formulas to calculate area and perimeter of a triangle. Next, I created a Boolean type variable. Then I created a while loop and passed this variable to it as condition. Then I printed the options. Next, I created choice variable and initialized it with readLine method to get user input. Next, I created the switch and passed this choice variable as condition to it. Inside it, I created case according to options, and inside each case, I used the shaped.add method to add new shapes in the list. Then I called the relevant methods inside each add method. Next, I created the static create circle method of circle class type. Inside it, I asked for user to enter valid value using getValidDouble method and stored the input in radius variable. Inside getValidDouble method, I created while loop. Inside it, I created if statement and asked for user input in the condition and converted this input into double type and stored the input in value variable and also set it to be greater than 0. Inside it, I returned the value variable. And in else block, I printed the error message. Then, I created new instance of circle class and passed radius variable to it. Then I printed the radius and returned the circle instance. Next, I created rectangle method of rectangle class type. Inside it, I asked for the length and width of the rectangle using getValidDouble method. Then I created the object of rectangle class and passed length and width to it. Then I printed the length and width and also returned the rectangle object. Next, I created create triangle method of triangle class type. Inside it, I asked for the 3 side of the triangle using getValidDouble method and store each input value in separate variable. Then I created the object and triangle class and passed these variables to it. Then I printed each variable and also returned the triangle object. Next, I created the display shapes method which takes list of shape class as parameter. Inside it, I used if statement to check if list empty and printed the message. Then I created for each loop which iterates over shapes list. Inside it, I printed the shape type, area and perimeter of each shape. Here, I also used F2 to print only 2 floating number. Now run the program. Options are displaying here. Now choose each option and pass values. Then display the shapes. And name area and perimeter of each shape is printed here. With this, Shapes Calculator app is complete. Now, we'll create extension methods. So, come out of this class because extension classes must be created on top level. Here, I've created a public static class named string extensions. Inside it, I created 2 static methods. First method checks if the words are palindrome, and second method converts the string into title case. Next, I created the static class named datetime extensions. Inside it, I created the 2 static methods. First method calculates the age till today. Second method checks if the day is weekend or not. Next, I created the static class named numeric extensions. Inside it, I created the 2 static methods. First method is a Boolean method and checks whether a number is prime number or not. Second method is to percentage method to get percentage of any fractional number. I have also set it to display only 2 floating point numbers. In main method, I have a string type word variable. Then I used as palindrome method on this variable. Next, I have a string type phrase variable. Then I used to title case method on this variable. Next, I have a datetime birth date variable and passed a random date to it. Then I used age method on this variable to calculate the age. Then I used as weekend method to check whether today is weekend or not. Next, I have an int type number variable. Then I used as prime method on this variable to check whether this number is prime or not. Next, I have a double type fraction variable. Then I used to percentage method on this variable to get percentage of this fractional number. Now run the program. Result is printed here. First word was palindrome, so it returned true. Second phrase is converted to title case. Age is also calculated correctly. Then it returned false as today is not weekend. Then it returned true as 17 is prime number. And finally, it printed the percentage of the fractional number. With this, extension methods are complete. Now, we'll create To-Do app along with the functionality to save tasks in text file. So here, out of main method, I created list of task type. Task is a class which have 2 properties, description and is complete. Next, I created a variable to store file path where I want to save my tasks file. Then in main method, I called the load tasks method to load task from the file. We'll see this method in a moment. Next, I printed the options for user. Then I created the input variable and initialized it with readLine method to get user input. Then I created the switch and passed this input variable to it as condition. Inside it, I created cases according to the options and also called the methods accordingly. Next, I created a static type addTask method. Inside it, I asked for user input and stored it inside description variable. Then I created if statement to handle the empty input. Then I used task.add method and inside it, I created new task by passing description variable and setting the isCompleted property to false by default. Next, I created the remove task method. Inside it, I called the list task method. Then I asked user to provide the task ID to remove. Then I created if statement and inside condition. I used the readLine method and converted the input to int type and also stored the input in index variable. Then I set index to be greater than 0 and less than tasks count. Inside it, I used tasks.removeIt method and passed it index -0 because lists are 0 indexed. And in else block, I printed the error message. Next, I created the list tasks method. Inside it, I checked if task count is 0, then print the message and return. Then I used for loop to iterate over task list. Inside it, I checked the status of task using ternary operator. Then I printed the task and status. Next, I created the mark task complete method. Inside it, I called the list task method. Then I created if statement and in condition, asked for user input to get the task index. Inside it, I set the is complete property of that task to true. And in else block, I printed the error message. Next, I created the save tasks method. Inside it, I used using statement and inside it I user stream writer and passed file path to it. Inside it, I used for each loop to iterate over tasks list. Inside it, I used write line method of stream writer to write the tasks and status in the file. Here, I separated the task and status by using the bar. Next, I created the load tasks method. Inside it, I used the if statement to check if file exists or not. Then I used the using statement and inside it, I used stream reader and passed file path to it. Inside it, I created string variable named line. Then I used the while loop and set it run till file ends. As I set line variable to reader.readLine method, each line from the file will be stored in the line variable separately. Inside it, I split the line from the vertical bar because while writing the file we separated the task and status using this bar. Then we stored both split parts in this string array named parts. Then I used if statement and checked whether parts length is 2 or not. Then I converted the task status to Boolean type by fetching it from parts array using index 1. I used index because arrays are 0 indexed and task status is the second value in array. Then I stored this Boolean value in is complete variable. Then I used tasks.add method and inside it, I added first value of parts array to description and also passed complete variable to is complete property. Now run the program. First add few tasks. Now check the tasks list. Tasks are printed here along with status. Now mark one task as completed. Now save the file. Go to file path to check the file. File is created and tasks are also saved inside it. Now, remove one task. Check the task list now. One task is removed successfully. Now save the file again. Check the file again. Only one task is saved inside the file now. With this, our to-do app is complete. That's all for this section. Congratulations! You've reached the end of this complete C# programming course. Over the past lessons, we've explored the C# starting from the absolute basics and moving into advanced concepts. We began with the fundamentals, understanding C# and the .NET ecosystem, setting up your development environment, and diving into core concepts like variables, data types, and operators. From there, we mastered control flow with if-else statements, switch cases, and loops. Next, we learned about object-oriented programming. You learned how to create and use classes, encapsulate data with properties, and apply key OOP principles like inheritance, polymorphism, and abstraction. We explored different types of classes, like static, abstract, and sealed classes, and discussed where and when to use each one. Then, we learned about exception handling, where you learned how to manage errors gracefully with try-catch blocks and even create custom exceptions. In the section on file operations, you discovered how to read from and write to files, manage directories, and use file streams for efficient data handling. To cement your learning, we built real-world projects. From creating a simple console calculator to building a fully functional banking system, to-do list application, and even a shape calculator to demonstrate polymorphism in action. We also created an extension method library showing how to enhance existing C# functionalities. Now, let's see how to utilize the source code. I have separated each section in separate file. Each file has a main method. To use it, code of main method must be copied and pasted in main method of program.cs file. Then, there are some files which contain main method and some classes outside the main method. For these, you need to copy code of main method to main method. And classes or methods, which are located outside main method, must be pasted outside the main method. Next, I placed projects code in separate folder. Inside these files, I also created main methods to make it easier for you to understand. Before you go, I'd love to hear your thoughts, like what was your favorite part of the course? What projects or concepts did you enjoy the most? Drop a comment below and let me know. Don't forget to subscribe for more advanced tutorials and exciting projects. Thank you for joining me on this journey. See you in the next video.